the next presentation.
Good afternoon, everyone. I am Ho Yok Ping from MWA, and I will be your moderator for this session. Our today afternoon third set topic is leak detection for transport pipelines, the Nautilus system that will be presented by Ms. Anna Cózar Bernal. Before the floor is passing to our speaker of this session, let's get to know our speaker. Anna Cózar Bernal. Anna holds a degree in Arabic philology from the University of Cadiz. She carried out postgraduate studies in international relations at the Toledo School of Translators and in business development with the Spanish Confederation of Business Organizations. Since 2018, she has been working in the International Business Development Department unit of Aganova, a Spanish company based in Malaga, specialized in technologies for leak detection and pipeline inspections. Anna is responsible for the coordination and implementation of the business strategy in the Middle East, Colombia, Ecuador, Chile, Europe, and Southeast Asia. In addition, she is currently participating in the work team for the implementation of projects to reduce unaccounted for water in Malaysia and the United Arab Emirates. It is to highlight that this is a live presentation by Anna, and it is welcome for you to key in your questions in the Q&A chat box. Anna will be answering questions after the presentation. And now pleased to welcome Anna from Aganova Group, Spain, to start her presentation. Let's welcome Anna. Thank you.
Hello. How are you? Thank you very much for your kind presentation. I'm going to share my screen now. Well, first of all, I would like to thank Mrs. Ho Yok Ping for her introduction, and I would like also to thank the Malaysia International Water Convention to invite us to present our technology today. In this presentation, I'm going to present you our leak detection technology specially designed for transport pipelines, the Nautilus system. I would like also to mention that our partner in Malaysia, Wavewater, is participating also in the Congress. So if you want directly speak about our services, you can go to Wavewater booth. They will be very happy to talk with you. First of all, let me just briefly introduce our company. Aganova is a Spanish company based in Malaga in the south of Spain. The company was created in 2010, and we were, at this point, we were offering leak detection at national level for water companies here in Spain. A short walk in the market, we realized that the existing technologies at that point, they were not able to detect the leak in transport pipelines, in big diameter pipelines. That's why we started the design and development of the Nautilus system, which was designed in 2015, and we started the commercialization at international level in 2016. From this moment on, there was a big change in the company. We changed from a merely service provider to a R&D based company. Today, I will briefly introduce also the Nautilus Platform, which is a future of our Nautilus system that has been launched this year. Without no more introduction, I'm going to explain the Nautilus system methodology. Nautilus is an acoustic method. It's a wireless, inline, and neutrally buoyant technology for water leak detection in big diameter. Briefly introducing the rationale behind our technology, let me explain that many of the existing technologies in the market for leak detection, they are acoustic. So this means that the leaks are detected and located because of the sound of them when the pipeline is pressurized. This technology, for example, geophone, correlators, loggers, they work from the surface. Okay, so they detect the leaks from the surface where the pipeline is buried. But there are many obstacles for leak detection in big diameter pipelines from the surface. For example, the material of the pipeline. Sometimes the material is not a good transmitter of the sound. The diameter of the pipeline itself, when the pipeline has a very big diameter, the sound is not very well transmitted. Or in many of the cases is the depth in which the pipeline is buried. So the idea of Nautilus is to insert the acoustic method inside the pipeline to be able to detect the leaks from a very close point. So we are very accurate in leak detection and leak and anomalies detection, and the location of them. Nautilus then consists on a sphere that is inserted into the pipeline. The sphere travels free, driven by the water flow, and what the sphere does is to compile the acoustic information within the pipeline. At the end of the section we went to inspect, we introduce a net to be able to catch the sphere, and then we analyze the information we have captured, and we can detect and locate all the leaks and anomalies found in this section. Taking into account that we can inspect up to 35 kilometers in one section, there is an element that we use to better accuracy of the system. This element is called synchronizer. What these synchronizers do? These synchronizers, during the inspection, permanently knock the pipeline. Knock. So when the sphere captures all the sound, it also captures the sound of these synchronizers. Then the sound of these synchronizers serves as a reference to be able to locate the leak at the exact point. It's very important to take into consideration that as the sphere travels free, it is important to close all derivations that could be in the pipeline we are inspecting. Now I'm going to show a video that summarizes what I have just explained. Here I summarize a little bit the Nautilus system benefits. As I mentioned, it can inspect up to 35 kilometers in one inspection. The detecting methodology is very close to the leaking point. We can detect very small leaks, such as 0.005 liters per second leaks. The error margin is 1 meter, to be able to a better accuracy of the system, we would need to have accurate information of pipeline drawings to be able to locate the leaks at the exact point. It can be used in any kind of pipeline materials. As mentioned, the technology is neutrally buoyant. This means that it flows freely in the center of the pipeline. This is to avoid to encounter obstacles such, for example, sediments at the bottom of the pipeline. It can travel vertically. It can be used at very low water speed. Of course, it can be applied at any depth. Let's just move on to the implementation of the technology. First of all, let's see the minimum requirements to be able to inspect a pipeline with the Nautilus system. We need water flow. Of course, if there is no flow in the pipeline, the sphere wouldn't move. The speed limits are the minimum are 0.2. The maximum speed limit depends on the diameter of the pipe. We also need to install synchronizer. The maximum distance between synchronizer is about 700 meters, and the installation of the synchronizer is very easy. We just need an element that is in direct contact with the pipeline, such as a valve or a hydrant, any element that is in direct contact with the pipeline we are inspecting. Also, we need pressure. As an acoustic method, to be able to detect leaks, it's necessary to have the pipeline pressurized. Minimum pressure, it's 2 bars. Maximum pressure is around 20 bars. Finally, I'm going to move on to the insertion and extraction points. The system includes the set of insertion and extraction structure. To insert the sphere, we need an operative gate valve of a minimum diameter of 80 millimeters. For extraction, we need exactly the same. We need an operative gate valve of a diameter minimum of 100 millimeters. The operation is very simple. We couple a pressure chamber on top of the valve. We insert the sphere or the net inside this chamber, and then we close the chamber. When the chamber is closed, the operator can open the valve, and then we push the insertion inside. When the sphere gets in contact with the flue, it immediately starts the travel. For the insertion of the net, the help is supported by a camera. So we insert the net, and we can see that the net is totally open and covers the whole diameter of the pipeline, and then we can proceed with the inspection. Finally, the results. What I'm going to show you in this screen what we find when we find a leak. Apart from leaks, let me just explain that we can classify these leaks in medium, small, large leaks, and we can also detect air pockets. If during the inspection we find another zones that are not normal within the pressurized pipeline, we mark this point to the client as an anomaly. For you to have a better idea of what is a leak and how we detect a leak, I'm gonna show you a audio of a detected leak. In this audio here, okay, we have heard a beep, beep, beep. This beep is emitted by the sphere. This beep allows us to detect the sphere pass from the outside with the help, for example, of a geophone. Now we have heard a tock, tock, tock. This tock, tock, So it was a synchronizer sound. And now we are going to listen the leak. I hope you have been able to hear this intensification of the sound, which was the leak. This leak, by the way, was a collar leak in an elbow. That's why the synchronizer was very close. So there was a linking point just in the point where the synchronizer was installed. Finally, as I mentioned at the beginning of my presentation, this year we have developed a new feature for our system. This feature is the NEMO platform. NEMO is a platform designed for the practical and effective monitoring of the leak detection campaigns. Through this platform, the client will be able to see the planification on the project, the inspection that are already done, the inspection that are planned, insertion and extraction points, and all the information about the leak detection inspection. It also records the execution of the jobs, and of course, it shows the results of the leak detection inspections and campaign. The client will also have access to this platform, so they can come back to the information done in a previous campaign to have a starting point to planificate a prevention campaign. I bring today here a couple of examples of jobs that we have developed in the past. This first example, it was one of the first inspection we did, and one of these inspection here in Spain. It was a pilot project done for the Suez Group, in which they wanted to test the accuracy of the technology. This pipeline was a 12 kilometers length pipeline. It was covering the center of a city. So it was the pipeline was very old, and it was very difficult for the client because of the outside zone to review this pipeline and to get information about the situation of this asset. We performed the inspection in one insertion and extraction. The insertion was performed through a gate valve of 150 millimeters, the same with extraction, and we locate 18 synchronizers this time. After the inspection, we detected 21 anomalies, 3 big leaks, 8 medium leaks, and 10 big leaks. This project was a success experience that was the starting point of a wider collaboration with Suez Group, not just here in Spain, but all over the world. Secondly, I bring here one of the biggest projects we are performing at the moment, which is a leak detection campaign in Qatar that intends to cover 700 kilometers of pipeline inspection that are covering the deserts of Qatar. The information here, it was the one we wrote for the interim report this year in May. In May this year, 550 kilometers of distance was covered, in which we found 188 anomalies and 91 leaks. This amount of leaks bring to a client a save of an economic save of 5,037,000 euros a year. We in Aganova, as I mentioned, we are based in Spain, but we work at international level. To be close to our client, we have a partner in each country in which we are working, which is around 60 countries around the world. In Malaysia, we are working with Wavewater, as I mentioned at the beginning of my presentation, and they will be so kind of answer your question if you address their booth today or this week in Malaysia. We have worked in many countries in all the continents, and we have success experience around the world. We have covered more than 2,000 kilometers of inspections so far, and we are about to double this amount in coming year. Of course, and for your information, I think it's interesting to know that, of course, our system is certified to work in potable water network by NS61 international certification. We belong to very prestigious, the very prestigious association of SWAN, Water Europe, and I Utilities. The system is patented in 61 countries, and for management purpose, of course, our company is certified by ISO 9001 and 14001 certificates. I think how you've been, this was my presentation. I don't know if you get some questions from the audience.
Yes, definitely. Thank you for the interesting presentation. Just now about the sound, I also hear the knock knock, and I also feel that the sound was so annoying. But however, that is how an operator need to work on that. Here we have a question to you from Mr. Stuart Stepley. His message has been sent as below. Hi Anna, nice to see you. How does the net cope with the pressure from the wet of the flow of water? Do you have a maximum flow rate that you must avoid exceeding to ensure the net does not break?
Yeah, there is a maximum velocity. We have to differentiate. For navigation, the water speed is not a problem. It is not a problem because it doesn't interfere to the leak detection. But we have to consider for the insertion of the nets that we have to manage the water speed. Let me explain that the net is like two flanges like this, that they are inserted together and they open when they get to the bottom of the pipeline. So these flanges are flexible. Depending on the diameter of the pipeline, we should remain the water speed between 0.5 and 1 meter per second.
So 0.5 to 1 meter per second. I see. So that is how you actually need to avoid is any size of the pipe while using the same velocity that you are using for measuring.
Excuse me, can you repeat the question?
I mean, any size of the pipe will be using the same flow rate that you are the flow measurement.
Yeah, it depends because if we are working in 250 millimeters, which is a smaller pipeline, we can inspect. The length of these flanges are smaller, so we can support a wider velocity. And then if we are talking about 1,600 millimeters, there is a long flanges to be inserted, yes. So the speed with the lower.
I see. Okay, so longer will be using a lower velocity. A smaller one will be a higher velocity. That is
yes.
Okay.
But if the client can manage just to modify the velocity during the inspection, for the rest of navigation, there is no problem. By the way, I would like to say hello to Stuart as well.
All right. Some of the question also including, can the sphere, because the sphere looks very small, just now when you mentioned it's so small, where he get lost?
It's like a tennis ball, 60 millimeters.
So is it easy to actually escape from the net or get lost from it?
Okay, this is very important because I mentioned that the sphere travels free. So first point, if there is any derivation or branch in the pipeline, we have to keep it closed. Then what we have to do is to do an accurate pre-inspection planning to avoid the loss of the sphere. For example, the net is designed to cover the whole diameter of the pipeline. And there is a camera that allows us to make sure that this net is covering so the sphere cannot escape. But there is another configuration. For example, if we have a blind tee in the pipeline. So we do in advance an in-depth study of the pipeline we are going to inspect, and we also deal with the client for a rescue plan. Let's imagine that there is an element that probably it is or not is. We have to make an in-depth study of the pipeline to avoid the sphere loss.
I see. Okay. So in case the sphere, I think the sphere is the heart of your overall system, right? So in case this one is, this sphere is breakdown or whatever, is it able to just replace the sphere by itself?
To use another sphere, you mean? Yeah,
yes.
Yeah, of course.
I see. Okay, that will be supplied from your side, is it?
Yeah.
So is there any like technicals?
It's important to mention, and I think I haven't mentioned before, that we offer Nautilus as a service. So we don't sell the equipment and the sphere, we offer the service. In collaboration with our partners, we provide the leak detection campaigns.
I see, meaning that your team will have to be at the site to conduct the overall service.
Exactly.
I see, okay. All right, so it's a special service that we require the whole of your technical team to come over to bring together with your equipment to do the leaking detection, right?
Yeah, sometimes it's necessary our team to travel. Sometimes the leak detection campaigns are deployed by the local team of our partner that is already, of course, trained to the implementation of the service.
I see. Okay. All right. Then this is much more easier. So meaning that there is many countries that you have your local technical team to actually help to do this kind of service. Right. Okay. Another question maybe can just sending to you is it safe to use the technology in portable water pipeline?
Yeah, it is safe. The system has been designed to inspect potable water. So all the materials and the construction of the system itself, it was designed to be able to be applied in potable water. And so also it's certified by the NSF 61 certification that certifies that these materials are compatible with potable water.
I see. So I have another question because I am from a wastewater line, which is if this is to be used in a sewerage system to detect the leakage, is it? Not
in all cases. It is important that the water is filtered, that are no solids in the pipeline we are inspecting. If there are solids, these solids would interfere in the capture of the sound.
I see. All right. So there is using for maybe clear water, or maybe if for the wastewater, maybe it's the recycled water pipeline. All right. Okay. So I think that's it for today. Thank you for all to attending to this presentation. For the next session is actually a technical tour that will be start at 5 p.m. And thank you very much for Anna for your presentations. And thank you. It's an interesting gadget to know. Right. Thank you very much.
Thank you very much. Thank you very much for all the attendees also today.
Thank you.